Hi GoTel, this is the tutorial for color mixing with the RGB LED. Let's go. We're going to measure the position of each potentiometer and then map it back onto the red, green, and blue values. Then we're going to write those values back into the RGB LED. So first we're going to create constants for the three analog input pins. So we're using constant integer function here. Red pot is 0, green pot 1, blue pot 2. Then we're going to create constants for the three RGB pulse width pins. So using the constant integer function again, red pin is 3, green pin 6, and blue pin 9. Then we're going to create variables to store the red, green, and blue values using the integer function. And then we're going to void setup, and we're going to set the RGB pins as outputs using the pin mode function. So pin mode, red pin output, and green for blue. And when we get to the void loop, we're going to read the three analog input pins and then store their value into the color variables using the analog read function. So the red value is going to equal the analog read of the red potentiometer, and same for green and blue values. Then we're going to use the map function to scale the 10-bit 0 to 1023 analog input value to an 8-bit 0 to 255 PWM or an analog write signal. And then we're going to store that new mapped value back into the color variable. So red value is going to equal map red value, and then 0 to 1023 is what we're starting with, and we're going to change it to 0 to 255. We're going to do the same thing for the green and blue values here. Then we're going to use the analog write function to write the color values to their respective RGB pin. So analog write red pin, we're going to use the red value onto the red pin, use the green value into the green pin, and the blue value into the blue pin. And that's it. This is the Arduino board for the basic code of color mixing with the RGB LED using three potentiometers. So first we have the RGB LED here, and it's grounded through this black wire, and it's connected to the negative column here that is grounded by another black wire here over to the ground on this side over here. Also, each of its pins are run through a 100 ohm resistor here into and then through a different wire to their pin. So the red LED pin goes through this orange wire into pin number 3. The green goes to the green wire into pin number pin number 6, and the blue goes to the blue LED goes to the blue wire into pin number 9. Okay, so then that's all for the RGB LED. We go to the three potentiometers. So each of these potentiometers is grounded through a black wire here, again into that negative column, and is grounded by the same black wire from before. Then each of them is connected to a 3.3 volts of power through these red wires here, and that's connected through this red wire here that goes into 3.3 volts. And then each of these potentiometers is controlling a different pin on the RGB LED. So the first one is the red pin, the red LED. So we follow through the yellow wire here into analog pin 0. The next is the green LED, so that's going to follow through the yellow wire as well into analog 1 pin. And the final potentiometer is for the blue. It's going to follow through another yellow wire into the analog 2 pin. So here, as we move each of these different potentiometers to on, more of the colors will turn on. So red, we turn all the way on. It's red. If we turn on the green one, it's very bright. And if we turn on the blue, it'll get to white. So if we go from lower, let's see the change. If it's just red and blue, you get the purple. There's different variations of color you can cycle through. This is the modified code for color mixing with an RGB. We're going to measure the position of each potentiometer and then map it to the red, green, and blue values, and then write those values onto the RGB LED as well as the three other red, green, and blue LEDs. The extra LEDs will dim or increase in light along with the RGB LED. And the code will also print out on the serial monitor the percent of light emitted out of each LED and RGB pin. So first, we're going to create constants for the 3 analog pins. So the 0, 1, and 2 are both analog input pins. Then we're going to create constants for the 3 RGB pulse width pins. So red pin 5, green pin 6, blue pin 9. We're also going to create constants for the 3 LEDs, but we're going to use the same pins as the RGB is connected to, so that the 3 LEDs will be dimmed at the same time as the RGB LED. So the same color LEDs will correlate. So that'd be 5, 6, and 9 again for the red LED, green LED, and blue LED. We're going to also create variables to store the red and green and blue values. So using the integer, red val, green val, and blue val. And then here we're going to use the float function to create these integers variables for the percent of light emitted to each LED and RGB LED pin. When we get to the void setup, we're going to set the RGB pins as outputs here using the pin mode function. And then we're going to set the three extra LEDs as outputs as well using the pin mode function. And then we're going to set the potentiometers as inputs. And we're going to set up the serial monitor at 9600 BAUD. When we get to void loop, we're going to read the 3 analog input pins and store the value to the color variables as red val, green val, and blue val for the red pot, green pot, and blue pot using the analog read function. And then we're going to use the map function to scale the 10-bit 0 to 1023 analog input value to an 8-bit 0 to 255 PWM, or an analog write signal. And then we're going to store the new map value back into the color variable here. For right now, it's going to be red value. So we do map red value from 0 to 1023 to, we're going to change it to 0 to 255. We're then going to print out the red value using the serial print. So we're going to tell it to print the red value equals as words, and then we're going to tell it to print the actual value that it found right here. Then we're going to do the same thing for the green value and the same thing for the blue value, each printing out the same things that we did for red, and then same thing for blue. Then we're going to use the analog write function to write the color values to their respective RGB pins as well as the 3 other LEDs. So the analog write function, red pin, we're going to use the red value to control how much light is emitted. And then we're going to find the percent of red light emitted out of the RGB LED by multiplying it by 100 and then dividing it by the 255. And then we're printing out the percent of the red pin into the serial monitor. We're going to do the same thing for the red pin here. So it's going to be finding that we're using the green value for the green pin, where we're going to find the percent. And then we're going to print out the percent green pin equals the percent green pin that we found right here. Same thing for the blue pin, except now we're just plugging in the blue value for the green value and the blue pin for the green pin. When we get to the red LEDs and the green LEDs and the blue LEDs, it's going to be the same idea as above, right here. That was right here, but instead of having the red pin, it's going to be red LED or the green LED or the blue LED. So that's the code. If we go to the serial monitor, it's going very fast, but if we pause it or scroll it, we can see that the red value is measured at 83, green value is 150, and blue value is 102, and the percent of the red pin is 32, and so is the red LED at 32, 58, 58 for the green pin, and 40 for the blue pin, 58% for the green pin, and 40 for the blue LED. And if we go back to auto scroll and we change the potentiometers on the board to different numbers, we can see that, pause again, that they are now different numbers as they were before. And that's it. This is the modified board for the modified code for color mixing with an RGB LED. So here we're going to start down at the bottom. We have 3 red, green, and blue LEDs here. They're all grounded through their cathodes into the negative column, and that's grounded by this black wire into the negative column over here, which is then grounded by this black wire here into the ground pin over here. Then each of these LEDs run through a 100 ohm resistor and into their towards the information wire. What's interesting here though is, so there are 2 wires on each of these pins. So the first wire is going to be connecting to the RGB LED, and the second wire is going to connect the information to the LEDs here, as well as the RGB LED into pins 5, 6, and 9, going from red as 5, green as 6, and blue as 9. So then when we get to the potentiometers, each of the potentiometers is connected to the 3.3 volts over here by connecting through this red wire here into the positive column, and each of these potentiometers is connected by a red cable into the positive column that connects to the red wire. Then each of these potentiometers is connected through a yellow wire here to their analog input pin. So the first potentiometer is analog input 0, the second is analog input 1, and the third is analog input 2. And then when we get to the RGB LED, the red pin, which is the first pin here, goes through a 100 ohm resistor into this orange wire here, which is plugged back in to where the red LED is connected. So it'll follow the same dimming or increasing of light as this red LED. And then the green LED is this third pin here, right here. It goes through a 100 ohm resistor through the green wire, it connects to the green LED down at the bottom, which connects it to pin number 6 eventually. And then when we get to the fourth pin, it is the blue LED, which goes through another 100 ohm resistor, connects to this blue wire, which connects it to the blue LED, which then brings both of these the information from pin number 9 to both of the red, the blue LED and the blue RGB pin. And then this RGB LED is grounded by this black wire here into the negative column, which is then grounded again by this black wire. So that's all the wiring, and we can see it work by adjusting each of these potentiometers. So this is the red potentiometer. We can see that both of them, the LED and the RGB LED, will increase or decrease in light. If we do the green one, same thing. And again with the blue. We can color mix with this, so we do the blue, go green a little bit, change colors, but you'll still see the individual amount of light that is contributing to the final color on the RGB LED by looking at the brightness of each of the individual LEDs. So that's it.